So chapter 6 is all about polynomials. Chapter 5 was all about quadratics. Everything was something squared. In this chapter, we're going to see cubic functions, quartic functions, quintic functions, raised to a higher power. We're also going to be solving them. And if you look on the back of our notes today, we'll also be graphing them. So we've seen linear, we've seen quadratic. Today we'll actually get into cubic and quartic and some of the quintic regressions. To start off, I just want to make sure this is all prior knowledge, what's on the front of the notes pretty much, that we all know how to name a polynomial by the degree and the number of terms, which was Algebra 1. Vocabulary: polynomial is a monomial or a sum of monomials. So these are all monomials, each of these that's shown on the board. A polynomial is when you put them together. The degree of a polynomial is the largest exponent. So since the largest exponent is 3, we would call this a third degree polynomial. In standard form, as I mentioned in the bell ringer, is when the terms of the polynomial are in descending exponent order. So cubed, squared, first power, and then a constant. Okay. All right, so if it has a degree of 0, it's called a constant function. An example would be just 6. You can also classify this by the number of terms. This only has one term, so that would be called a monomial. So below they'll ask you to simplify and classify. They'll say by degree and by the number of terms. So there's two different classifications. The next one, if the degree is 1, it's linear. For example, x plus 3. This one has 2 terms. Who remembers what 2-termed polynomials are called? Yep. A binomial. Very good. And this is just an example. Like you could have a linear monomial as well, like just 2x. But this is just one example. And then our quadratic is if it's degree 2. That's what we just focused on. Now this one happens to only have 1 term. I know you see 2 things, but it's what's being added or subtracted. Like this one has 3 terms. This one only has 1 term. So that would also be a monomial again. Cubic function is a degree of 3. This one has 1, 2, 3 terms. Who remembers what we call a 3-term polynomial? Garrett? A trinomial. And then you may or may not be familiar with these. I feel like cubic you would be, but maybe not. So quartic, you'll want to know that word, stands for 4th degree. And quintic stands for 5th degree. So those need memorized if you don't know them already. So the quartic one, again, has a 4th degree exponent. This one has 2 terms, so that would be a binomial. So it would be a quartic binomial, putting the 2 names together. And the last one is quintic. Our degree is 5. Now this one has 1, 2, 3, 4 terms. After 3, you don't have any special names for the number of terms. So you would just say that this is a polynomial of 4 terms, or a polynomial of 5 terms, 6 terms, whatever. But you will have monomial, binomial, trinomial, and then after that just say of how many terms. So below we have 3 examples that ask us to write each polynomial in standard form first. So we may or may not have to combine like terms and reorder the value so that it is in standard form, which again is in descending exponent order. Then we'll classify it by the degree and by the number of terms. Okay, so the first one, we just need to rearrange these values to make it x cubed plus 9. That's standard form. Who thinks they could classify this by its degree and the number of terms? So is it linear, quadratic, cubic, quartic, or quintic? And is it a monomial, binomial, trinomial, or something else? Who can name this? Abby?
Cubic, binomial.
Very good. Cubic, degree is 3. Binomial, there's 2 terms. Remember doing this in Algebra 1? No? Okay, the next one. Now be careful. When you rearrange terms, the sign in front of the number has to stay with it. So this would be a negative 3x to the fourth minus x cubed minus 2x squared. So make sure you have that negative, bless you. Who could classify this by the degree and number of terms? Garrett? Good, a quartic trinomial. And then the last one, we actually could combine some like terms. 4x minus 6x is negative 2x plus 5. And who can classify that for me? Clint, what do you think? Linear. Anne has very good trinomial. Alright, so you'll see some on your homework that just ask you to do this. Now they also may ask you to actually perform some operations, like adding, subtracting, multiplying, or dividing pairs of polynomials, and then classifying them. So this next set asks us to simplify each, shrink this down a little, simplify each expression and classify it by degree and number of terms. So this is kind of like what we did with, remember the imaginary numbers where we were adding like a plus, or 5 plus 2i plus 7 plus 3i, and we basically distributed the positive sign, which does nothing.
I'm just learning.
Did you need something?
I just wanted to learn from that.
Okay.
Did great work.
Thank you.
Find us.
No, I had to remake mine.
Yeah, that's fine.
Got my files back. Flip chart's all gone. Open the flip chart folder, empty. Geometry, I still have my flip charts because I did back up my whole geometry. Algebra, gone. Okay, so they won't be as fancy. The one that I did find this one that had all the things on it. That was in Algebra 2 from like 3 years ago. All right, so the biggest mistake I'll see here is that some students will FOIL this. Okay, you'll do like a whole bunch of work you don't have to do. So just make sure you realize that if there's a plus sign in between, you're adding the two things. You're basically just adding like terms. So negative 8x cubed plus a negative 1x cubed will be a negative 9x cubed. And then negative 7 minus 6, negative 13. Now below, there is one we'll have to FOIL, and that's when there's no symbol in between them. This would be a cubic binomial. Example B is subtracting. What do I have to remember to do when I subtract? Caleb? Good, you have to distribute that negative to change the sign of each thing in the second set. So this would become minus 3x cubed and plus 9. Everything else stays the same. Go ahead and combine your like terms. And again, I like to combine my like terms in descending exponent order so that it's already in standard form. So we should have 2x cubed. Now there's nothing I can combine with this, but I would bring it down so that it's in descending exponent order. And then we should have 17. Who can classify that for me? Ashley? Cubic trinomial. All right, now the next one will be our hardest one. We have 3 binomials being multiplied together. How do we multiply if there were just 2 of them? Or to cover this up? What do? Garrett? FOIL, right? So you're going to have to FOIL 2 of them and then distribute the third one, okay? My suggestion is to FOIL the second 2. It doesn't really matter, but for some reason it looks easier to students in step 2 if the second are the ones that are foiled. I don't know why, but I suggest you foil the second 2, but it does not matter, just foil 2 of them. So I'll bring down the x minus 1, just keep it as is, and then I'll foil this one. And I am going to leave parentheses, but I'm going to have like a big set of parentheses. So we'll get x squared plus 3x minus 2x minus 6. You do want to combine your like terms before you move on. So combine like terms to get x squared plus x minus 6. That kind of looks like a second. All right, now this is the part that gets a little bit harder. It is kind of like foiling, but foil, you have 4 arrows. In this case, you're going to have more than that. You're going to have 6 things that are being multiplied. So we'll start with the x. X is going to get distributed to everything in that second set. Okay? So x times x squared would get me x cubed. X times x will get me plus x squared. And x times a negative 6 will get me a minus 6x. Second thing we need to distribute is the negative 1. Make sure you're using the negative. That has to get multiplied by everything in the trinomial. So this will get me negative, or minus, 1x squared minus 1x, and a negative 1 times a negative 6 is a positive 6. Okay, this is why I tell you it's easier if you foil the second 2, because students usually like to draw their arrows going this way instead of going backwards. But it doesn't really matter. Now all you have to do is combine your like terms and write it in standard form. So x cubed can't be combined, but I would bring it down first. So it's in descending exponent order. We have a positive x squared and a minus x squared. Those would become 0. We have a negative 6 and a negative 1, which is a minus 7, plus 6. Who can classify that? Awesome. Perfect. Okay, so that was the hardest one. The next one's actually easier. What do I have to do when I see this squared? Write the term twice, which is called expanding it. So 2x minus 1 times 2x minus 1. And then this is just a simple FOIL. So go ahead and FOIL that. See what you get and classify it. While you're doing that, I'm going to open up my graphing calculator. You'll need your graphing calculators out, so if you don't have them out, go ahead and grab them. And if you don't have theirs today, go ahead and grab one from the back. Clayton, what'd you get for D?
4x squared plus 4x.
Perfect. And Rayleigh, how'd you classify that? Quadratic what? Triangle. Okay, good. Quadratic triangle. Okay. So on the back, what we're going to do is, just like we've done linear regressions and quadratic regressions for pressing the stat edit button and putting in our list, you can do cubic and quartic models. Same thing. So we have already used linear, or lines, and parabolas to model data. And those were linear and quadratic. And you'll remember we did this with scatter plots, and we would see like which one was the best fit. Sometimes you can fit the data more closely by using a polynomial model of a degree of 3 or greater. So all I have right here, this is a picture of your graphing calculator. These are all of the parent functions. Remember, the parent function is before it's been stretched, shifted, left or right, up or down, flipped, all that kind of stuff. This is the most basic version of it. So we see our linear, our quadratic. So the cubic looks like this. Now, a lot of times once we apply like 2x cubed or 2x cubed plus 1, sometimes it will look more like this. Okay, so if you want to jot that down. It'll actually look almost like a sideways S, so it goes up, comes down, and then it goes back up again. Right here, it actually just like levels out and then goes up again, but once you add in some different numbers to it, it will look more like that. And then our quartic right now kind of looks like a parabola also, but we'll see what it can look like when we adapt and model it. So below, the examples ask us to use the graphing calculator to determine whether a linear, a quadratic, or a cubic model best fits the data. Okay, so in order to know which one best fits the data, we have to do all 3 regressions, and we have to check and see, compare the R squared values. So you might remember we looked at the R value when we did linear, and that was called the correlation coefficient. It told you which one, how closely it fit the data. Was it a strong positive, a strong negative, that kind of stuff. When we're looking at quadratic, cubic, and quartic, we're going to compare the R squared values. Okay? So you want to make sure you have those diagnostics on, which we should have them on from the beginning of the year. But some of you may have reset your calculator or something, and it may have gotten turned off. So let's just make sure they're on. Oops. Okay, so to turn your diagnostics on, you'll press second 0, which is catalog. And you can either arrow down until you get to the D's, diagnostic on, or you can press the alpha button and then the letter D. And it'll jump down to the D's. And then just go down until you find diagnostic on, and you'll hit enter 2 times. And the catalog is like the index. It has like every single possible thing your calculator can do if you aren't able to find it. So diagnostic on, hit enter 2 times, and it should say done. Okay, so now your diagnostics are on. They should stay on unless you reset your calculator. All right, so to find our regressions, we're going to press Stat, Edit. My lists are cleared out. You may want to clear yours out. Remember, to clear them, you hover up to the top. So it's highlighting L1. You hit the Clear button. Do not hit the Delete button. You still want to have those. And we're going to input, this is our L1, and these values are our L2. And then we're going to actually do a linear, a quadratic, and a cubic, because that's what the directions ask us, to determine which of those 3 is the best fit. Sometimes it'll tell you just find a quadratic or a cubic regression, but this one wants you to find all of them. So we'll press Stat, arrow to calculate, and we'll choose the linear one first. Okay. And so for the linear, we can see that our R squared value is 0.129. Our R value also, which we've looked at before, is 0.359. Okay, we're going to do the same thing for quadratic and cubic, and we're going to see which one is closest to 1, which means it's the best fit. Okay, so you don't have to retype the data, just press Stat, arrow to calculate. This time we'll do a quadratic, option 5. Hit enter. Now, you'll notice for the quadratic, it only gives you an R squared value. It doesn't give you just an R value. So R squared is 0.998. And you could write out more if you want to. Sometimes they'll be very close and you have to figure out which one's actually closest to 1, because that looks like it's going to be the best, but let's wait till we see the cubic. Okay, so stat, arrow to calculate, and choose option 6 this time for cubic. This one, the r squared value is 0.9985, which would be 0.999. So the cubic model is best. So we're supposed to find the model. Now it has a bunch of decimals. We're just going to round them. I chose to round to the nearest thousandths place as we write it out. So this would be 0.002x cubed minus 0.184 x squared plus 1.488x plus 2.789. Just rounding the nearest thousand. Now, you also can store that in your calculator if you prefer. I don't know if any of you remember how to do that, but we can store that in our y equals using the y vars key. And then they do want us to use this to estimate the value when x is 30. So we have to plug in 30. For x. Now, it may be easier to store this in our calculator, and those of you that have the new calculator, this will be significantly easier for you, but those of you that have the ones I gave you, you'll have to type a few more buttons. So, if you remember, to get this whole equation to go here, without having to type it all out, go back to stat, go back to calculate, and do your cubic regression. Just don't hit enter. Okay. Then we're going to put in L1. I think we have to put a comma first. No. I think we can just do L1, comma L2, comma y bars. Those of you with the new calculator, you just have to go down to where it says store equation, and you're going to press the y bars button, which I'm going to show in a minute. We have to do L1 for all of us on our old calculator. So second 1 will get me L1, comma, second 2 gets me L2, just telling me to use list 1 and list 2, comma, and then you have to tell it where to store it. Where to store it is under the vars, which think of it as variables. Okay, so press the vars button, arrow over to y vars, choose option 1, which is functions, and then select y1. Those of you with the new calculator, that's the only buttons you have to press to get the y1. And then hit enter, and hopefully it works because I didn't put my, yes, it did, good. All right, so it looks like it just did what we did last time, but if you go to your y equals, ta-da, it's all typed in for you. So you didn't have to punch in all the buttons. Oh, shoot. Let me just do that again. Just trying to delete this function. All right, now, if we want to evaluate 30, go to your table. Second graph, and you can either scroll down to 30, which might take you a little bit, but obviously a lot faster, or something you can do is you can modify the table. You can tell it to start at 30. So what I did was I pressed second table set, and I'm going to press 30, go back to my table, and it actually jumps down to 30 for you. But you could obviously just scroll. And I get negative 61.85. Now, if you don't like that, you could have just taken 30 and plugged into here. It'll get you a slightly rounded differently answer because you're not using all the decimals, but it'll still be pretty precise. Okay. All right, I'd like you guys to try example 5 on your own. This one will be easier because it tells you that you're only finding a cubic model. You don't have to do all 3 this time, just find a cubic model. But also pay attention to what the directions say. Let 0 represent the year 1975. when it tells you to do this, you're actually letting this be 0. This would be 5 years later. This would be 10 years after that, 15, 20, and 25. And those are the values that are going in for L1. These are the values that are going in for L2. And then all you're doing is finding a cubic model and using it to estimate the number of employees in the year 1990. Oops. So in the year 1998, what would we be plugging in for X? We'll be plugging in 1998. Abby? 23. So to figure out what you're plugging in, you just need to take 1998 and subtract what year 0 was, which was 1975, and we'll get 23. So we're looking at when X is 23, what is the Y value? So again, I already stored that into my Y equals using my new equation. I just have to go to my table. It's probably the easiest thing. And then just go to 23. And I get approximately 59 employees. Okay, and you should have had the equation written out. I'm just not going to write it out since I have it here on my calculator. Okay, the rest of the time is yours to get started on that homework assignment. I will pull up on hand, so if you want to come up and see, I mean, obviously not everyone will have time to see what they got wrong on their quarterly, but if you want to come up and see, we can start a line.